Hey class, this video is on graphing parabolas in standard form. Before we get to that, we need to talk about something else, and that is with a parent graph of a parabola. This is a parabola. This is the parent graph, which is y equal to x squared. We have certain points that are plotted here. An essential thing to notice is a pattern with the parabola. Now, I'm going to begin at the vertex. If I go 1 to the right, I'm going to go 1 up. This 1 that I go up is essential here. I'm going to go 1 to the right and then 3 up for that next point. Trying to get from this point to this point, I'm going to go 1 to the right and it is 5 up. All right, same thing will be replicated on the left hand side, but this pattern is important to notice. All right, if we were to keep going, the next number would be 7. Right, the pattern here is odd numbers. Right, 1, 3, 5, ... Right, we keep going, 7, 9, 11, so on. So this is an essential thing that we need in order to graph parabolas. Okay, having said that, let's go ahead and look at the steps on graphing in standard form. There are only 2 steps. The first step is to find the vertex. To find the vertex, we have this formula over here. This actually comes from the quadratic formula, which we're going to be learning soon. In order to find the x-coordinate of the vertex, we take negative, we're going to find a b value and divide it by 2a. Okay. This a and b value, they come from this right over here, which is standard form, f of x equal to ax squared plus bx plus c. And to get the y value, what we have to do is this says f of negative b over 2a, which is this stuff. Whatever that x value is, we're going to plug it back into the function. We're going to input a value, and whatever the output is, that is the y coordinate of our function, of our vertex. Okay. Step 2, we need to use a pattern, right? That pattern that we had noticed on the parent graph, 1, 3, 5, and we're going to be using that. But an essential thing here is we need to multiply our a value. Our a value in standard form, what this does, this can stretch a parabola, compress it, or reflect it, right? For reflecting meaning that it's upside down from this upward orientation. Okay. All right, we're going to get to our first example, which is this one, which is f of x equal to x squared plus 6x plus 8. So again, first step is to find the vertex. We always begin at the x value. Right, that's negative b over 2a. But what I'd like to do before I begin is always identify what are a, b, and c values. So let's go and write that off to the left. A value. The a value in standard form is a number in front of your square term, your quadratic term. In this case, it is a 1. So I'm going to go and put 1 right there. B value is in front of your variable with an exponent of 1, your linear term. In this case, it is a positive 6. And your C value is your constant, the number that's by itself. In this case, that is a positive 8. Okay. Well, of our x value, it's negative b over 2a. So I'm going to put negative, our b value is 6. And 2 times a is 1. We're going to go ahead and simplify this. Negative 6 divided by, well, the denominator simplifies to 2. And negative 6 divided by 2, negative 3. Okay. So we found our x value of our vertex. Now we have to find the y value. What I do is I take this and plug it back into our function. So let's go ahead and rewrite that. So instead of putting f of x, I'm going to put f of negative 3 equal to, I'm going to go ahead and put parentheses wherever I see an x in the original function. So instead of writing x squared, I want to put negative 3 squared. Instead of putting 6 times x, is 6 times negative 3. And then we just have a positive 8 that's left over. Simplify from here. Negative 3 squared, negative 3 times a negative 3, so positive 9. Positive 6 times a negative 3 is a negative 18. Then we have a positive 8. We're going to simplify from left to right. 9 minus 18 is negative 9. Negative 9 plus 8 is a negative 1. So when our input is -3, our output is a -1. Okay, so our vertex, meaning that it is -3, -1. We're going to take our graph and go and plot that there. So -3, -1 is I go 3 to the left and 1 down from our origin. So taking our graph, we're going to go 3 to the left, 1, 2, 3, and 1 down. So this is going to be the vertex of the problem. That's the turning point of it. I'm going to go ahead and draw the axis of symmetry. When you have a parabola, the axis of symmetry, it evenly divides the left and the right side of it. It's perfectly symmetric. I'm going to draw a dashed line for that. That's the equation x equal to -3 right there. And remembering from, so that was step 1. Step 2 is to find the vertex, or sorry, to find the pattern. We're multiply a times this sequence. Now we found our a value. Our a value is 1. So pretty easy to multiply with 1. I'm going to go ahead and show what that becomes down here. So 1 times this sequence. I could keep going, but these numbers, that's pretty sufficient. So we're just going to distribute. 1 times 1 is 1. 1 times 3 is 3. And times 5 is 5. Okay, so let's go ahead and graph this. So from our vertex is our starting point. These values are all positive. These values tell us how much we're moving up and down. If they're positive, they move up. If they're negative, they move down. So taking this, I'm going to move 1 to the right, and that +1 tells me it's going to be 1 up. We're going to move 1 to the right, and then 3 up. 1, 2, 3. And 1 to the right, that last number was a 5. 5 up. 1, 2, 3, 4, 5. Okay. We always move 1 to the right. That never changes. We're going to replicate this on the left-hand side because this is symmetric. So it's 1 to the left, 1 up. 1 to the left, 3 up. And 1 to the left, 5 up. And these give us some nice points to try to draw the graph of our parabola. Okay, so there we go. This parabola is the graph when the quadratic function is x squared plus 6x plus 8. Alright, so just to recap, we found our vertex using, well, the x value of our vertex using -b over 2a. To find our y value from our vertex, we plugged it into the original function. Our output was our y value. We graphed our vertex on the x and y axis. And then we multiply our a value times this pattern we noticed from the parent graph. That shows us how much we move. That's our step function for the parabola. Alright, so that was the first problem. I'm going to give it another problem over here. And this next problem, this is our last problem, I would recommend pausing the video, try to graph it yourself, and then replay it to see if what you graphed is accurate. Okay, so we have f of x equal to -3x squared plus 6x plus 2. Okay, so go ahead and pause it now, identify your a, b, and c values, find the vertex, and then graph. Okay. Alright, hopefully you unpaused it. The graph, or we're going to start trying to find the a, b, and c values for this. So our a value is -3, b value +6, c value +2. We're going to plug the a and b value into this formula for x of a vertex, x equal to -b over 2a. So we're going to have x equal to negative, our b value is 6, over 2a is 2 times -3. Let's simplify this. This is going to be -6 over -1, which simplifies to be +1. Okay, that is the x value of our vertex. To find the y, we plug it back into the function. So we're going to have f of 1. Typically, I'll rewrite this, but just put parentheses wherever I see an x value. So we're going to put a 1 in for all these x's. Order of operations for this first term is always exponents. So 1 squared, that's just 1. And then we multiply. Negative 3 times 1, negative 3. 6 times 1 is 6, and then plus 2. This will simplify to be positive 3, and 3 plus 2 is 5. Okay, meaning our vertex is going to be 1, 5. So 1 to the right from the origin, and 5 up. So 1 to the right, 5 up, right over here. Again, draw your axis of symmetry. Now, something that's a little bit different from this function than the last one is our a value. The last one, our a value was easy. It was just positive 1. In this case, it's a negative 3. So what we'll do is we're going to take negative 3 and multiply it by this sequence of numbers. Multiplying it, this will be negative 3, negative 9, and negative 15. Okay, let's remember this. So meaning starting at my vertex, I'm going to go 1 to the right. And that first number was negative 3, meaning I'm going to go down 3 since it's negative. So 1, 2, 3. 1 to the right, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, I believe is right there. And down 15, it's not going to fit, but these 2 points work fine. Okay. Let's replicate this on the left-hand side of the axis of symmetry. So 1 to the left, 3 down. And 1 to the left, 9 down. Go ahead and draw the curve for the parabola. Since this value is bigger than negative 1, or sorry, less than negative 1, this is a stretch. So it's vertically stretched. If we're in between 0 and 1 or 0 and negative 1, that would be a compressed. It would look a little bit flatter. Okay, so that was the graph of f of x equal to negative 3x squared plus 6x plus 2. If you guys have any questions, let me know. Bye.